Here we are back, Titans, on episode 9. That's over section 13.2. Again, general angles and radian measures, except for now we're going to go with part 2. Our goal today is to be able to convert from radians and degrees to each other, and to also find arc lengths and area of sectors. So let's jump right into it here. When we convert between degrees and radians, to rewrite a degree measure in radians, so to go from degrees to radians, you multiply by pi radians over 180 degrees. And to go the other way, you multiply by 180 degrees over pi radians. That'd be a really good thing to write down. Those are very, very important today. So let's do a couple examples. If I'm going from 110 degrees to radians, I'm going from degrees, so I'm going to go 110 degrees and multiply that by pi radians over 180 degrees. Well, what happens is the degrees on top and the degrees on bottom cancel out. You're just left with radians. So I multiply straight across 110 pi, and we can just leave pi in our answer for radians, over 180. I'm going to simplify that to 11 pi over 18 as a 10 comes out, so 11 pi over 18 radians is my answer. And when we're in radians, we can just leave it like that. Now to go the other way, from radians to degrees, I multiply by 180 over pi, and what happens is the pi's on top and the pi is on bottom, so they automatically cancel out. So what I'm left with here is negative 180 over 9, and negative 180 divided by 9 is negative 20 degrees, so negative 20 degrees is equal to negative pi over 9 radians. These are all equal. This is just a conversion here. 180 over pi is just a conversion, as they are the same. Okay, so from going degrees to radians, multiply by pi over 180. Radians to degrees, multiply by 180 over pi. Alright, so next thing we're going to talk about is arc length and area of a sector. Basically what we have here is we can cut out a section of this circle and we call that a sector. This would be a sector. The arc length is going to be how far it is around the curve on the outside of that sector. And we'll call that S. Arc length is called S. The radius of the circle is just going to be from the middle to the outside, just like normal. This central angle here would be this angle right in the middle. We'll call that theta. And what we'll do is we'll find the area of this, so how much space it takes up, and then we'll also find the arc length. And our formulas are arc length, which we'll call S, is equal to r times theta, so the radius times theta, and area equals 1/2 r squared times theta. Now the key here is that theta has to be in radians, so you might have to convert it first from degrees to radians. That is the big key. Theta has to be in radians, so remember that, star that, write that down, double write it down, double underline, whatever you got to do there. Very important. So let's go ahead and do one here. Find the arc length and area of a sector. Well, here I'm looking for the arc length of this sector. I know that theta here is 60 degrees, and I know that r is 10 centimeters. Well, I need to get that theta into radians, so I'm going to multiply by pi over 180. And I get 60 pi over 180. Well, that simplifies down to 1/3 pi. 60 degrees is 1/3 pi. So now to find arc length, I just take 10, my radius, times 1/3 pi, my angle, which gives me 10 pi over 3. And it's arc length, so that's going to be centimeters. You could leave it like this, or you can multiply out 10 times pi divided by 3 gives me 10.466 centimeters, which is a little easier for me to read than 10 pi over 3. Okay, so that is how to find arc length. Radius times theta in radians. Next one we'll do is to find area of a sector. Again, we got to make that theta be pi over 3. Now I'm going to use my formula. Area is 1/2 r squared over theta. I'll plug those in. 1/2 10 squared times pi over 3. Multiply across. 10 squared is 100. 100 divided by 2 is 50. So 50 pi divided by 3. And again, you could leave that as your answer, or you could go ahead, take 50 times 3.14 divided by 3, and you actually get 523 centimeters squared. It'd be centimeters squared here because it is area, so use your centimeters and square it. Make sure to label. So there is arc length and area of a sector. Here's an example for you. Go ahead, pause right now, see if you can do that. Use these two formulas. Alright, hopefully you paused. Now we're back and we're looking. R is 3 inches, theta is pi over 4. Man, theta is already in radians, so we're good there. So arc length is 3 times pi over 4, or just 3 pi over 4. And make sure to label 3 pi over 4 inches. And you can leave it like that or multiply out. Then to find the area, I'll take 1/2, 3 squared, times pi over 4. Well, 3 squared is 9, so I get 9 over 2 times pi over 4, which gives me 9 pi over 8, and it'd be inches squared since it is area. And again, you can multiply that out if you want, or just leave it in terms of pi. Alright, last example here. Go ahead, see if you can pause, find the coterminal angles, and then convert the bottoms into radians and degrees. So pause here, see if you can solve these 3 problems, and then come back. Alright, hopefully we're back here. Remember, when finding coterminal angles, you are going to add 360, and you are going to subtract 360 from these. So I get 570 degrees. And I get negative 150 degrees. The other ones convert. I'm going to take 325 times pi over 180. That just gives me 325 pi divided by 180. I'll simplify that by taking a 5 out of each of those. I get 65 pi over 36, and we'll label it radians because it converted to radians, and you can leave it like that. Then the next one, 9 pi over 2 times 180 over pi this time. Pi's cancel out. You get negative 9 times 180 is negative 1620 divided by 2. Oops, not 8, divided by 2. And that is 810. Negative 810 degrees is my answer. And that is it for Section 13.2. We will come back to class, do some more in class, have an assignment in class, finish up that worksheet. Otherwise, that is it for today. Have an awesome one.